invite Professor Dr. Mürüde Çelikağ to deliver his speech on a case study, progressive collapse analysis of existing reinforced concrete buildings.
Thank you very much. I would like to start by extending my appreciation to all those who are involved in the organization. It is a very nice organization, and we would like to also thank Zeki. It was an inspiring and quite exciting projects that he shared with us. I will bring you back to our reality here and talk about a study they have done some years ago and looking at some of the typical buildings in our country, reinforced concrete buildings, and looking at their progressive collapse possibilities. Let's see if I can read this word. So I want to start with briefly defining the progressive collapse for those who may be not so familiar. We are looking at buildings being subject to unexpected loading, such as some errors due to design and construction causing unexpected loading in parts of the building, fire, impact, gas explosions, and in more recent years we've been seeing terrorist attacks. And as a result of such situations, we may get some member collapses, which may lead to partial collapse, and eventually, if the redistribution of loading doesn't end up with an equilibrium status, this may continue, and eventually it may go for total collapse. There are a number of examples which is widely known, and there are different typologies like, as I put here, pancake type, domino type, zipper type, goes on section type, instability, and mixed type collapses. Most common, one of the most common is probably pancake type, and World Trade Center is the famous one, which recently was the anniversary for the attack in 2001. And that's another picture of it. These are some examples around the world due to terrorist attack, or like the Windsor Tower due to intensive fire, then Kobar Towers, again terrorist attack. There is the one on the right, the Commonwealth 2000 Commonwealth Avenue, which is due to lack of shoring and low concrete strength. And most of these unfortunately cause numerous people to die, or thousands of people to die in some cases, and also property loss. One of the early examples is the Ronan Point apartment in London. It was a load-bearing paneled structure where there was a gas explosion at the 18th floor, causing collapse in that level or damage, and then the upper floors collapsing on top of the following, creating the dynamic effect and part of the building being collapsed. And there's another one, Alfred Murray Federal Building, which was damaged due to terrorist attack. So what we need to do is to increase the structural redundancies, and irrespective of the initial damages to primary members, concentrate on how this will affect the geometry of the structure and how we can provide the load path so that eventually the additional loads can redistribute and eventually get to a stable status. Many nations try to develop design codes. USA was one of the first, General Services Administration and Department of Defense. They produced a couple of documents. In this study, we used the DoD, the Department of Defense 1, with linear static procedure. Of course, there are other procedures, but we use the linear static because it is quicker, economical, it is suitable for less than 10 floors. We use the direct design approach and alternative path methods for this study. It is suitable for different materials like reinforced concrete, civil structures, etc. So using this method, we need to remove columns or bearing elements, vertical members from the middle of the short side, middle of the long side, and corner of the building. The process is given on the right, column removal. It should be from the bottom floor, top floor, and somewhere in the middle. In this study, because the middle wasn't, because it is 4 floors and 8 floors, we had to do all floors for the 4th story, and for the 8th one, again, we did 4 floors. Then analysis carried out, redesign, identified members that failed, they were retrofitted and finished. So the main objective is to find the how this column removal or which particular one is more effective, like the short side, long side, or the corner of the building, at which floor, and as a result, the building height, how this influences. Of course, there are limited number here. As I said, 4 buildings, 2 of them 4-story, 2 of them 8. From the dimensions, you can see that they are more or less same on plan. These are also selected on the basis of providing the structural regularity needed. The buildings are constructed between 1992 and 2004, according to Turkish standards. It is not that time frames. 3D models done by sub 2000, and then the rest of the analysis and design done. These are the reinforcement in members for the 4 buildings, for 4-story on the left and 8 on the right. Generally 14 sides longitudinal bars with different numbers, and 8 and 10 diameter bars for the stirrups. And according to DOD, we need to report and categorize the members. As a result, for 2 types of approach, the formation control, force control, each building was analyzed and redesigned 96 times to get to the point. I'm watching the time because it's very limited time. So this is the first building, and the removal locations for the columns are given, and I try to highlight the area so that you can see the span between the columns, and when you remove the column, what sort of area is highlighted. What we notice is generally first floor removal of column gave the highest number of failures. You can see there. There were notional loads also applied in principal sites of the building, and there wasn't much difference according to that. North, south, west, east. You can see that the number of members failed are more or less similar. This continued in the second 4-story building. This time, and I should highlight that it is the short side. If you look at the overall dimensions, it is this short side that was critical in all of them. But as we get to the 8th-story building, again, we are looking at the short side here, removing of a column from there. But you can see that the failure of the members are more close when you look at removal of column from different floors. And that's the final last building, 8th-story again. There are quite high number of failures, so even the 2 8th-story buildings are not the same. The failure number of members are different, but still the concentration is in the first floor, short side. And there is also long side in this particular building. Those at the top is corner, long, and short. And those are the deformed shapes given at the top for the removal of short side and the corner one. This is just altogether the same information. I will pass that. If I try to summarize this, again, considering the time, Generally, we should be looking at the span. When the span changes and gets larger, when you remove the column, if it forms a bigger area, naturally you get to have more damage in that case. This also further summarizes. Again, I said the notional loads, depending on which direction it comes, it doesn't make much difference for these particular buildings that are concerned and looked at. Then there was the retrofitting. After retrofitting, the members' section sizes changed, bars changed so that it can be capable of carrying these loads. So these are mainly, the study was done on the first floor, the removal of a column. Finally, what we find out from this short study, it was the middle of the short side of the column removal from that side at first floor was the most critical one. And we need to do more studies to confirm this because it is not easy when the buildings change. This is more regular building. When you look at other buildings, then you may come up with different results. The higher the building, clearly there were more failures, probably as expected. But again, this may not be a routine thing that we should get. So we need to do definitely more studies to try to standardize probably what is needed. And also to look at the economical analysis side of it, because when you are doing this kind of analysis, you will be looking at a building that there is a potential of progressive collapse. And in our countries, generally, we do get impact. There has been several cases, even in recent times, that lorry may hit a building which causes an impact. It's not always a terrorist attack, but there are other situations or due to material as well. So we need to look at such things. And nowadays we have even higher structures becoming more regular. Therefore, that needs to be looked at as well. But the time spent in this particular study, it should be justifiable of the end results. So it needs to be further worked on and identify these. Thank you very much.